Your AI-powered application just returned a 200 OK response code. The response was fast and there were no errors in the logs. And yet, it still hallucinated, leaked a credit card number, and burned $12 in tokens before anyone noticed. That's why AI applications need their own observability. In this video, I'll cover what you actually monitor for an AI application and why those signals matter. Then I'll show you what that looks like inside of Splunk Observability Cloud. For years, monitoring and observability were built around mostly predictable and deterministic request paths with standard red metrics. Agentic AI apps break that. A single user prompt fans out into an orchestrator, multiple agents, LLM calls, tool calls, and vector database lookups. The same prompt might take a different path the next time. Even though the request can succeed technically, the answer itself might be wrong, irrelevant, or unsafe. Classic APM tells you the system responded, but it doesn't tell you whether the AI behaved. Here's 4 groups of signals you would want to monitor for an AI application. Number 1 being performance, requests, errors, latency, throughput, the classic red metrics, cost and token usage. Quality. AI responses aren't just pass or fail, they're more or less good. The standard pattern is LLM as a judge. A second LLM scores each interaction against rubrics like hallucination, relevance, bias, toxicity, and sentiment, prompt injection, PII, PHI, and PCI leakage. Those risks need to be mapped back to the specific agent, model, and tool that was involved so you can contain the blast radius. Splunk Observability Cloud gives you all 4 pillars. It's built on OpenTelemetry's GenAI semantic conventions, so every LLM call, tool call, and agent step shows up as a span. The first stop is the AI overview page. Across the top, you get aggregate requests, errors, tokens, and estimated cost. Below that, charts for error rate and latency that you can break down by model or provider. Further down, token usage and cost, also grouped by model and provider. And at the bottom, a quality chart tracking hallucination, relevance, bias, toxicity, and sentiment, and a risk chart for security and privacy issues. If you need to dive deeper, we can visit the AI agents page. This is a list of every instrumented agent in your environment. For example, a travel planner app might have a hotel agent, a flight agent, and a coordinator. For each one, you get health, requests, errors, duration, input and output tokens, estimated costs, and quality and risk scores. Quality score is the percentage of evaluations that passed. Click an agent name and you drop into a detail view with those same metrics as charts. So if your hotel agent suddenly starts hallucinating, you can see exactly when it started and what changed. You can utilize the AI trace data page to further troubleshoot your AI applications. This is a searchable list of every AI trace and span. You can filter for things like show me only traces with a hallucination flag, or show me traces where PCI leakage was detected. Click into a trace and you get 2 things: the standard APM waterfall showing every span, and an agent flow graph showing how the requests move between agents and tools. Pick any span and open the AI Details tab. You can see the actual input, output, model, token count, cost, and the eval scores attached to that one call. AI applications fail in new ways: drift, hallucinations, silent tool errors, cost creep. Fixing those problems is important, but you can't fix what you can't see. Observability is the foundation. See every call, every hop, every dollar, every bad answer tied to the exact agent, model, and prompt that caused it. If you're interested in trying this out for yourself, sign up for the free edition of Splunk Observability Cloud using the link in the description below.